The falling object model is something used a lot in physics, and it actually it just kind of tells us how long it takes something to hit the ground or what height it started at. There's all kinds of things we can find. What we're going to always be finding is we're always going to be finding how much time it took. So the idea here is, let me tell you about the variables. T stands for time in seconds, and it's always in seconds. Okay, H stands for the ending height. Let me make a little note of that, ending height. Okay, so if it's hitting the ground, the ending height would be 0. S stands for the starting height. Okay, so wherever it started at. So if we're looking here, let's say we have an apple up in this apple tree, and all of a sudden it breaks loose and it falls to the ground. The question is, so let's say it's here and it falls to the ground. The question is, how long does it take for it to hit the ground? Okay, now let's say right here it was 25 feet off the ground. So that means if it's 25 feet off the ground, that means the starting height is 25 feet. And I'm wondering when is it going to hit the ground? So that means my ending height is 0 feet. Now the rest I just fill in. The negative 16 is just the effect of gravity in feet per second. And then we have t squared. So now it's a matter of solving this equation. Okay, now just like any other math problem, we first want to get rid of our extras, our green guys, so we subtract 25 from both sides. So now we have negative 25 equals negative 16t squared. Then I want to get rid of the negative 16. I'll divide by negative 16 to do that. So I have 25 over 16 equals t squared. Then we will square root both sides to get rid of that. The square root of 25 is 5. The square root of 16 is 4. And we're going to do a plus or minus equals t because the square root and the square canceled. Now we want to pay attention. Anytime you do a word problem, you want to pay attention to your final answer. We got a plus or minus 5/4. Now here's the thing. Negative 5/4. That means the apple would hit the ground in negative 1.25 seconds. We need to go back in time. So that's not a possibility. So we're not going to really pay attention to that negative. Our answer is 1.25 seconds or 5/4 seconds for this problem. Now let's do another problem. Okay, another problem, let's say we have a window and there's a planter on the window ledge. And all of a sudden it just tips over and it hits the ground. So how long did it take for it to hit the ground? So what we're going to do on this one is we are going to plug in 10 for S because it started out at 10 feet. It also, we want to hit the ground, so we want H to be 0. We plug in the rest of it just like it was. And then we'll start solving. So I subtract 10 from both sides. So negative 10 equals negative 16t squared. We're going to divide by negative 16 on both sides. And so we get 10 over 16 equals t squared. Now I know it's really tempting to simplify the 10 over 16. However, we don't want to do that because the next step is that I have to square root both sides. And if I simplify the 10 over 16, I won't be able to square root the 16. So the t, or the square root and squared cancels, so I get t equals. And over here I have the square root of 10 on top, over the square root of 16 is 4. And now this is something you'd actually plug in your calculator to figure out what it is at the decimal. Because to tell someone that it's going to take that planter to hit the ground in the square root of 10 over 4 seconds, nobody's going to really understand what that means. So you want to plug this in your calculator and figure it out, and whatever that is going to be your answer in the positive form. Of course, we're supposed to have a plus or minus, but it doesn't make sense for it to go back in time. And so that's how you use the falling object model.